Hi class, today I want to go over how you're going to do your calculator ramp lab. The goal of the lab that you're about to do is to determine the coefficient of static friction between your calculator and the ramp. The coefficient of static friction, if you can't remember, is that symbol mu, and static friction is the friction that prevents it from moving. We've done a lab just like this probably a little over a month ago. What we did is we had our lab tables, and then you guys might have taken a shoe or your calculator or your backpack or a water bottle, and we went ahead and we pushed that object to the right at a constant speed, and then we were able to calculate out friction, and then using FF equals mu times Fn, we solve for the coefficient of, in this case, kinetic friction, and we were solving for mu right there. We're going to do kind of the same thing, but instead of pushing it at a constant speed, we're going to use a ramp. So what you guys are going to do is you guys are going to go into class, and you guys are going to, for each table group, you guys are going to go back and you're going to grab one of the 1 meter long, the 3 foot long tracks in the back of the room. Not the really long tracks, not like the 6 foot long ones, but the 3 foot long tracks. Okay. You're also going to have a calculator in your group, so hopefully somebody has a Casio or a TI. Then you also need to grab a protractor. A protractor, I probably showed you guys in class already. The big ones that we have look like this. There's a little cutout right there, and then there's like a little weight right there, and then you can see all the angle marks right there. So to do this lab, what you're going to do is you're going to lay your track flat on your table. So this is the tabletop. This is the little track right there with its little legs on top like that. Okay, and then you're going to rest your calculator, so I'll put that in red. Your calculator is going to rest right there, and then you are going to slowly raise this up. So what will happen is, and I'll draw this over here on the right, sorry. So here's your tabletop, like right there, and then you're going to be raising up your track, so it's going to be like that, and you're going to raise it up so it gets to a height where this calculator just begins to go ahead and slide down the track. You're then going to hold that still, try not to move it, and you're going to take your protractor, and there should be little grooves there, or you can just rest the grooves on top of the track. So the protractor looks like this, and that little weight's going to be hanging down like right here, and you should be able to look at the angle mark along there, and maybe your angle theta is, I don't know, could be 50, could be 70 degrees. I'll just say it's like 60 degrees. That's the angle that caused the calculator to start moving down. If I were you guys, since we're calculating out static friction in this lab, you may want to just go down 1 degree. So at 59 degrees, that's the most static friction that we can have. At 60 degrees, I guess it's technically kinetic. So maybe just round down your degree mark, so 59 degrees, and then you're going to do that 3 times. So maybe you raise it up again and you get 60 degrees, and then you raise it up again and you get 58 degrees. And then you'll average those. So your average theta will be, in this case, 59 degrees. Yours might be different. You're also going to go to the back of the room and put your calculator on the scale and get how many kilograms it is. And based off what you've already learned in class, off the angle of the ramp and the mass, you guys should eventually be able to solve for Fn, and you guys should be able to solve for FF using horizontal and vertical forces. And then ultimately, you guys should be able to solve for FF equals mu Fn, and you guys should be able to solve with that formula. You should be able to solve for mu. Now in this lab, there's 2 parts to it. One part is just the calculator, just like the plastic part. Okay, I'll put that up here on the top right. And then the second part is to use the rubber feet on the calculator. So maybe your case or the backside of your calculator has the little rubber legs or the rubber feet on it. So the first part is without the rubber feet, and the second part is, and you should notice how much the coefficient of static friction goes up because of those rubber feet. If no one at your table has a calculator with those rubber feet, you could either borrow one from somebody else, or you could just test your calculator, and then maybe the second part you can make a note and maybe you test something else. Maybe you test your water bottle, or maybe you test a pencil or something like that. So as long as you have kind of 2 tests in there of different surfaces. That is about it. Enjoy your lab. I will talk to you soon.